Hi everybody and welcome back. In today's video I'm going to be testing the transmission rates of different transparent objects and materials, as we want to find out how light travels through different transparent objects and how much light actually comes out the other end. Some of the objects that I will be testing today are commonly used both in indoor and outdoor grows, while some of the other objects that I will be testing is primarily out of curiosity or to have as reference points. Too much light can burn plants, while too little light can hinder growth. It's important for any grower to know how much light is received by the plants, and with that in mind, adjust the lamp's height to deliver the ideal amount of light. Different plants have different light needs, measured in PPFD, and you can most likely find out what your plant needs if you search for the plant's name online or the plant type together with PPFD. Before we get to measuring, I'd like to point out that this video will only be informative to you if you have some basic understanding of what PPFD is, and simply put, it is light intensity at a certain place, or light particle density, or photon density. All light consists of photons. Intense light has a high quantity of photons, whereas a low intensity light has fewer photons. With an Apogee MQ500 quantimeter, we can accurately measure how many photons hit the sensor every second. The higher number, the more intense is the light. A very simple but clear example is taking a lamp and pointing it at a flat surface. If we lift the lamp only slightly, we'll see that the light footprint, the area that is illuminated, is only about as large as the lamp, but with a very high intensity. But as we increase the distance between the table and the lamp, the light footprint increases, while the density decreases as the light is spread over a larger area. This will measure the intensity of light, the number of light particles, the number of photons in micromoles per meter square per second, and this value will change depending on the intensity of light. Transmission rates can vary slightly depending on the light source and the spectrum that the light source puts out. For example, grow room glasses, or also even sunglasses, are usually made of PC, polycarbonate, as this material naturally is very good at blocking UV light. What we'd like to test today is how much more of the intensity is reduced by certain glass and plastic objects in the light's path. How much of the intensity is reduced by Saran wrap covering your seedlings, and what's the difference between giving your plants unobstructed direct sunlight versus sunlight that has traveled through a window. Let's find out. Hey guys, how's it going? It's time for a new video. My name is Max, and my wireless microphone just gave up on me, so I'm stuck with this super long cable. But without it, the audio uptake would be shitty, so I'm stuck with it for now. Hopefully it won't be too annoying. So today I'm going to experiment with transmission and how good or bad an object transmit light, as light can be reflected, absorbed, and transmitted. Different rates for different objects. Yes. So for this we are going to use the MQ500 quantimeter. The Z2 is hung from the ceiling, centered above the sensor at a height of 113 centimeters, which equals 44.5 inch. This results in, I've lit a candle for increased visibility, but also because it's cozy. This increase in a PPFD of 100, which makes it super easy to calculate the transmission rate. And the PPFD is 100 with no walls at all. And this is just a white blanket as example, but either way. It increases the PPFD. That's why I have a super black outfit today. So, and by the way, the ambient PPFD is 0. So, I've used my imagination the best I could, and I have come up with these materials. Some glass from a glass shelf from the refrigerator. Some glass from the oven hatch. A pan supposed to go in the oven, but not today. Seed starting box. And we want to find out the transmission of the lid. Soda bottle, bottom and top. I've seen it being used as small domes for seedlings, so thought it might be interesting to know. 3 types of glasses, color correcting ones. These are my computer glasses. They are supposed to reflect blue light. It's almost visible. It is. Maybe not relevant, but could be interesting. And these are my favorite grow room glasses, and you will see why in a couple of minutes. A recycled lunch container, maybe food container. The lid, going to test the lid. Saran wrap, cling wrap, food wrap, plastic wrap. Same thing, different names. In Sweden, we call it plastfolie. So we're going to test the transmission rate of this. Also test the lid of this box, as I've seen it being used by people that have dogs or cats that want to protect their seedlings before they are replanted outdoors. And also if they all have small children. So it might be interesting. I have measured the thickness of the different materials with this bad boy. Super handy, and thought it might be interesting. The more stats, the better, right? Last but not least, I have a window that we will be testing, because the other day I was measuring the PPFD from here at about 12 o'clock, and the sun was not even almost shining from a 90-degree angle. It came from way up there, so both from above and sideways, which creates pretty low transmission rates. And as I have a really good lamp and a really good light sensor, I figured I must, and also I have a window, I feel that I must, it's my responsibility to test what the difference is when light comes from a 90-degree angle. All right, let's measure. Some food containers for support. Let's start off by testing the different plastics, then glasses, and then glass. It's a shame, this one. It turns itself off every 2 minutes. Not super helpful. All right. Starting with this lid. The plastic type is PP. And the thickness is 1.5 millimeter. I will be moving it slowly across the sensor because it will show different PPFD values based on what part is above the sensor. All right. The lid of seed starting box, 0.4 millimeter thick, unknown plastic type. The small lid from the food container, PET plastic type, thickness 0.2 millimeters, so half the thickness compared to the other lid. Moving on to these two, the soda bottle, and I will be placing it with the sensor, touching one of the sides and slowly move it across, and you will know why in just a second. Same goes for the top. Starting with the bottom, sensor touching the side, progressing towards the middle. That's about the middle. I want to clarify that this focusing effect is done or achieved when the sensor is centered and the light is coming from right above. If we move the sensor off centrum at 50 PPFD, easier to calculate, and we center the bottle again, we do not achieve the same effect. And as you can see, depending on which angle the light comes from, the hotspot will change position. And continuing to the other side. Pretty interesting. Top, same. Side, moving in. This is the center. this is the other side. Might be good to know and not be completely unaware of the focusing lens effect. Moving on to glasses, this is my computer glasses. I'm measuring all the glasses, lens down, and leaning it toward against the sensor, the top of the sensor. Color correcting glasses. And these guys, my favorite. They are very good at what they are supposed to do. Always wear the recommended gear. Obviously, you only have one set of eyes. My favorite grow room glasses. All right. One of the most common materials to cover your seedling tray with. The Saran wrap, which has a thickness of 0.01 millimeters and is made of PE, plastic type. One layer of wrap, 2 layers of wrap. Pretty easy math. By the way, this is also PET and the bottle, and the thickness is 0.3 millimeters. All right. Moving on to glass. Oven pan, 5.7 millimeters thick. Oven hatch, 3.9 millimeters. And lastly, refrigerator shelf, 3.2 millimeters. I had an idea that maybe one of these was treated to be hardened glass, shatterproof glass, not sure what it's called, and that maybe that had some effect that would alter the transmission. But I'm no glass expert yet. So if any of you guys knows, please share with me in the comments. And if I have forgotten or missed any material or object that would be interesting to test, let me know, and I will do my best to include it in one of the coming videos. So only one thing left, and that is the window. '77. Simulating the sun moving across the sky and window 45 degrees. PPFD changes. And this is a double glass window. And now it's a single glass. So there you have it, guys. Transmission rates. And how light works. A little bit, at least. The big lamp is lit. It's a beautiful day. It is noon, end of April. And we have about 780 versus